Okay, so I have the first item, and that is that I want to share a little bit about the rollout of one of the new RPCs we built for the Git fetch efficiency project. And let me just share my screen. So this is a CPU utilization graph from the process exporter, which shows data summed across all Gitly servers in production. And it shows two process groups. One is Gitly hooks here at the bottom, and one is Gitly. And Gitly hooks, it was created to make very small, relatively boring RPC calls, but when we introduced the cache, it became a conduit through which all pack file data has to pass. So then it started using a lot more CPU. And the first new RPC we deployed and turned on changes what Gitly hooks uses. And you can see here the moment when we turned it on. So that is a nice drop in CPU. I should add that I believe this graph undercounts CPU utilization because Matt looked into this, and I think it only samples running processes when the Prometheus scrape happens. So if a process runs and finishes in between scrapes, it doesn't get counted here. If we
it's definitely on an interval. It's not constant.
Yeah.
Yeah.
So we're missing short-lived processes, and Gitly hooks is exactly a short-lived process. So there will be more seconds spent in on CPU time for Gitly hooks than this graph will show. Now, the other nice thing is that if you look at this graph of Gitly CPU utilization, then you also see a drop. And in absolute terms, it's actually a similar drop, because here we're in the, say, mid-90s. And here we're in the mid-hundreds, between 100 and 110. So it's a drop of about 10 CPU seconds per second. And here, well, this is a slightly bigger drop here. It's something like 18, and now the peaks are 4, so that's 14 CPU seconds per second. But it's the same order of magnitude drop. And it could be that we also deployed something else to Gitly at the same time as that I changed the feature flag. But I think it makes sense that it was this.
You mean the client side of it or the server side of it?
This shows the client side impact. This shows the server side impact.
And that's the server side. So effectively, that drop would probably be the server side impact of the hooks.
Yes, of the different hooks transport. Yeah. But we
seems logical. I mean, it seems like a reasonable assumption to make.
Yeah, I thought so too. Thanks. But yeah, we can't really be certain because we just don't have enough insight into. Well, the Gitly process does a whole lot of different things, and some of it is spent on these hooks. But we can't go back in time and say, well, at that time the Gitly process spent X% of CPU seconds on hook traffic. We can a little bit by looking at the Google Cloud Profiler, but it's hard to get useful data out of that, I found. So that's one thing. And then another thing I wanted to show is gRPC message rates. And I have to filter this if I want to show a graph, because there's too many servers and too many RPCs, and we don't have a recording rule for these. So if I try to draw a graph across all servers, it just won't render. So this is the primary of the prefect cluster where the handbook lives. And what you can see here is that you have these little bumps, which are back objects hook, which is the RPC we replaced. And here these bumps are gone. And it's interesting that these peaks are up. I don't know what's up with that. But the good thing is that these are post-upload back messages, and we're going to replace that RPC too. So these peaks will roughly drop to 0. Not literally, but we will have only one response message per call.
There's no chance that that's like the server has more bandwidth and it's therefore sending more traffic or something. Like it's kind of, because this is obviously messages sent.
Yeah,
So there's
it could
is it
be.
higher possibly because it's got more available CPU to do things? I mean, I'd be
Actually,
surprised if it was that announced, but
yeah, maybe I should just use Thanos directly here. Network transmit trans. Why is it not auto-completing? Network transmit bytes.
no,
A node,
that's
this
all.
one.
Yeah.
Oh, and then I can select. I don't understand what this thing is doing. FQDN is file prefect 2.star. Okay.
You need a rate on that.
Yeah. And I need to exclude localhost. Vice is not localhost. Right. And then that was 20 days. Does that look different? It doesn't really look all that different to me.
No. If you do 1 hour or something like that, just instead of 10
right.
minutes.
Actually, I forgot what interval. I did the same above. Yeah.
Yeah.
That should give us a better graph, but it's not. Doesn't look
Not
that
really
different.
anything there, is
No.
it?
So I'm not sure what's up with that peak. But we will bring that peak down, because that is literally the second step of the project, is to make this not go via gRPC messages anymore. I did try to get some global numbers, but for that I could only do a table instead of a graph. And I did a 1 day rate and a 1 day rate offset by 1 week. So that gives us something to go by. And you see that 1 week ago, we have 300K for post upload back, 200K for SSH upload back, and 100K for backup objects hook. And now we have 300K for post upload back, 200K for SSH upload back, and then a drop to 10K for info refs upload back, which is a order of magnitude less. So out of the top three, it's sort of 3, 2, 1, and we've dropped the one that was 1. But I don't know if this is a good measure for the improvement, but if this means that we can expect a drop in CPU that is 3 times bigger once we patch this up, that would be very nice, but I think that's wishful thinking and we won't know until we get there. But anyway, it's this is a nice story. Of course, this graph looks more dramatic when you don't have the big one up top, but I wanted to show how the two correlate.
Can you just for our entertainment purposes only, can you drop the Gitly side of it?
Sure.
That looks really good.
Yes, yes, it does. But it's only one small piece of what's going on, and yeah, no, it does look really good. And it's interesting because we have had an ongoing support escalation with a customer where they're concerned about Git fetch performance. And it looks like the overhead of the hook executable is part of their problem, although a lack of concurrency limits is also part of their problem, I think. Because I heard that sometimes they have 700 concurrent clones on a single server, which is never going to be fast. But
do we ship any concurrency limits in Omnibus?
no, I think they're all off by default.
We should probably put some in.
Yeah, because well, right now, as I can, the way I see it, from where I'm sitting, it looks like there's a difficult conversation going on, convincing them to turn those limits on. And if it was the default, we wouldn't even be having the conversation. But
yeah,
a lot of people, including Matt from our team, are on top of that, and I don't want to get more too mixed up in it. I think a lot of people who know what they're doing are spending time on that particular issue.
Yeah, the
But
thing
the
with
nice
the
thing
limits is that they avoid saturation, and actually everything would probably be quicker if the limit was there.
exactly. Yeah,
Weirdly,
unbounded
yeah,
concurrency is never good, but it's
yeah.
for some reason it's a hard sell in that case. But to connect this to that support situation, it's nice that we can show that that thing that is using a lot of CPU in their case is dropping by 75% in the latest release.
And I think, I don't think it's only that customer. Like, I've certainly heard of other cases of, where I'm sure this is going to benefit other customers as well.
Yeah, once this is
So,
working properly, it should benefit a lot of people. Yeah. But part of the story here is also that when we built the cache, the plumbing of the cache, the fact that we make this extra RPC call back into Gitly and that the cache is implemented there, that adds overhead. And for people who are not using the cache, they are getting the overhead and they're not getting the benefits of the cache. And when we worked on this on GitLab.com, it appeared that the overhead didn't really make a noticeable impact. And it's more uniform if you just always have the same data path and if you can get already log cache keys and stuff like that. So at the time we decided, let's just always go through the hook. But it turns out that in their situation, the overhead of the hook does matter. But yeah, on top of that, unbounded concurrency is also a problem. But what they're actually going to do now is to, I think, backport Gitly patches to not use the hook when the cache is off, which will help that particular installation.
So just remind me, is the cache only on as a setting that people turn it on specific repositories or specific Gitly hosts?
It's a per host setting.
Yeah,
and it's off by default.
Would it make sense in future to have it on by default especially once this changes in?
Perhaps. One of the concerns we had at the time is that, especially on the handbook repo, we write every byte that gets served into the cache. So if somebody's hosting GitLab on a Raspberry Pi with an SD card as the repository storage, then all their traffic becomes SD card writes. Well, that's a very exaggerated and contrived example, but it's doing a lot of writes can have a negative impact. A lot of disk writes can have a negative impact on the whole server. So we were concerned about just dropping those disk writes on everybody. And in our case, we're fine because the disks are fast and yeah,
I've got to go and take care of a snake.
Good luck with that.
I'll see you guys in a minute. Bye.
Well, I hope we see Andrew back in a minute. Jakob, quick question for you. Is this the MR3812? I linked it in the demo.
Let me see what that is. No, that's a different one.
Okay.
But this one, I think, made this bump a little lower. Is there something special about that MR?
No, I'm trying to find the MRs you're talking about, because this type of performance saves, even if they're not reliable across every single self-managed customer, would be nice to highlight in the blog post, release blog post. And I know you're not necessarily interested to highlight those things, but I think we should, given that there is a lot of work that goes into this.
Yeah, I do want to highlight these things. And I'll add a link to the rollout issue to the agenda.
Excellent.
In the upcoming, this change is feature flagged, and in the upcoming release, I asked with the Gitly team, and they want the feature flag to be off in the upcoming release because we're calling a new RPC. So otherwise, during a deploy, Gitly hooks would start calling an RPC that doesn't exist. So it would be next release +1, where we can tell people that it's on.
Okay.
And another thought I had is that I hope that at some point in the near future, the project is done and we can write a blog post about the impact of the project. And that would also be publicity.
Okay, great. I think it's more important than ever now to actually show that we are having some actual orchestrated work helping with some resource consumption and performance improvements and so on. So keep that in mind. So I already see that you are, so that's good.
Yeah. Yeah, and in the case of this, I don't know when you joined or how much you caught of this story about this support escalation with the self-managed customer. I can tell from the reactions that people have been communicating this work towards the customer, so it's we're already using it there to show. Of course, that's just one audience member we want to reach with this message, but it is being communicated already as
awesome
what we have. Yeah, but yeah, so the really big hope I have is that if we look here and we see that before we made this change, back objects hook was 100,000, and SSH upload package 200,000, and post upload package 300,000. And I'm getting very, sorry, I need to put the graph back where it was. Getting very optimistic now. And I want this page to load. This is going to. So this drop, I'm now thinking from here to here, is because of 100,000 messages per second less. Now, if we have 300,000 messages per second less, does that mean we get a drop 3 times bigger? That'd be really nice, but I don't know. But we may have a nice graph to show when that happens, when we get there. Because then we're talking about, because this is a drop of about 10, and the whole graph is 100 to 110. So a drop of 30 is near 30%. So that's a lot. But the real thing I'm hoping for is that what I'm hoping to see is that these bumps on these app-text graphs of GitLab servers, that we have fewer of these. That is really the thing we're going for. Thanks.
Then we could maybe add the bumps again by allowing more RPC calls in the app-text metrics.
No, well, I don't think, are we filtering calls that we shouldn't be filtering?
We're filtering calls. I don't know. I think we're filtering too many of them, but yeah.
Because some of the ones we're filtering, we should be filtering, because if we say that you cannot expect a 1 gigabyte clone to happen in 1 second. So if the repo is 1 gigabyte,
it's only unary calls, and it's a subset. It's a basket to indicate, and it's anything that is like that is generally taken out. Like I think the biggest unary one is maybe archive or something like that. There's a whole bunch, but yeah, no, I mean the most of the slow things are out of there. It's basically looking for like get commits that are slow.
Well, one thing I remember,
which is a good indicator.
Yeah. One thing I remember changing is that operation service, which is part of GitLab, which makes merge commits and things like that. I think that got excluded.
That's gone now. It became its own service with vastly broader thresholds, and now it's gone. So because it was just noise. We couldn't get it to kind of play nicely. So we kept adding things to the exclusion list, and then the problem was that the RPS on the service got so low because we'd excluded so much of it that it wasn't very good, and then it just became noisy, and then we just said, let's kill the thing. And so operation service is now totally excluded from all.
Yeah, as a whole.
Yeah, which is probably what we should have done, but you live and learn.
Yeah, it's.
Can I just say one thing? Yeah. It's going to be amazing when the teams that drive and own and build these services are the ones putting those thresholds on there, not some guy in infrastructure who's guessing what the RPC does. Andrew. Yeah, or any of us, but you know how much better that's going to be, because they'll be able to say, like literally, we don't care about this because of X, Y, or Z, and it's going to be so much better. Think like from that point of view.
Yeah, because right now the durations of stuff is like I don't remember, like satisfied is 1 second, but like a git commit that takes 1 second is or find commit, or what the RPC call it.
Finding commits should be fast, but the reason operation surface is problematic is that it's creating commits, and some of
Yeah.
these commits have validations on them that can be very expensive, and that's why it gets super slow. So it's
Yeah,
on
right
one hand,
now,
users are waiting for them because they click merge and they see the spinner, but on the other hand, there's things out of our control that can make it slow, which is a ground for excluding them, I think.
yeah, but that's the reason that what Andrew said, like if we pull that apart and we can say find commit, which we sometimes do hundreds of times within a request, needs to be faster than, I don't know, something lower than a second, but then that thing that you just mentioned to create a merge commit or whatever can be different.
Yeah. I think what's also happening here is that with Gitly, we've been defining these alerts for way longer than in general with error budgets. So they're more refined because of that. But yeah, long term, it should be easier. Oh, that's what we're working towards, right? That teams can own these things.
That's the plan.
What do you mean by more refined? Because I was looking at the Gitly service just now, and like the things, like the SLIs there don't seem like super accurate to me. But yeah, that might be me.
Yeah, I would say, like Jakob, that they are probably the ones that receive the most deltas and changes because of the amount of alerting. Because we have the per node level alerting, which is kind of unique. Well, it is unique in our system. And we get so many more alerts because we're effectively dividing the SLIs, 60 ways. And we have 60 different buckets that we're putting those in. And therefore we get much higher volume of alerts. Because of that, people are changing them much more frequently than almost any other one. And so I would say that there's probably we probably need to go through them at some stage and kind of get everything in order, because there's probably been 1,000 small changes that people have done as they are fed up with getting an alert at 3 o'clock in the morning on a Saturday morning, or whatever. And it probably needs some consolidation, is what I'm trying to say, because that file's probably changed more than any other.
Yeah, but I don't think the kind of filtering we have there would be like a stage group saying this route should be excluded and this route should not be excluded, and this route is this, and like we have different threshold categories in the application, and that level of detail, no stage group can currently say that about their requests. That's what I meant by refined. That the way the metrics catalog is organized, we can point out individual RPCs and ignore them or not.
Which brings us a little bit to what I was going to talk about, unless there's something more you want to add, Jakob.
Go ahead.
So wait a second, share my screen. No, here. So right now this is running on my local. It's producing graphs that are not as impressive as the ones that Jakob was showing because they're fake. But these are the SLI kind of metrics that we want to, like, this is going to be the metric that we will allow stage groups to set thresholds for, and it's going to have two counters, the total counter and a success counter. What I wanted to point out here is this nice period where everything's zero. This means that we will have a recording when the Rails application has just started on a new pod, for example, where before that would be missing, now that will be zero, which makes it easier to calculate with, and it will avoid like missing metrics like we see now for error budget, when suddenly there's a huge spike or a huge drop when a metric starts to record when it's coming from nothing to something instead of going past zero. This also means that we will not have like one side of the graph being there and the other not. This shows the number of metrics. So this is the number of endpoints that we have in total, and we can see that total and success is the same. Like, yeah. The thing that I wanted to discuss here is that number. It's 2,570 different counters times 2 because we have total and success. And that's going to go onto our fleet. So that means times the number of pods times, yeah. So that could go fast. One idea that I had while working on this merge request was limiting what endpoints we initialize in the beginning based on the fleet that we'll be emitting them from. So for example, the API fleet doesn't need to initialize all the controllers, only the GraphQL controller, but it does need to initialize all the API, the grape endpoints. The Git fleet only needs to initialize the internal endpoints and the Git controllers, like that kind of stuff. So I was wondering if that's something we need to do, or that we should just ignore and make sure that our Prometheus instances can handle it. I don't have much more to show, so stop the share. Anybody have thoughts on that?
So it's funny because I came into this call having spent quite a bit of time with Grzegorz, because he recently added, or someone in one of the teams that he works with added some metrics, and they were they couldn't even run it in table mode, you know, with the 1 minute rate, and it was just crashing. And the kind of people are saying, well, now that everything is in pods, it's just like the cardinality of everything, and everyone's kind of starting to complain about this as becoming a big thing. The very interesting part was that we then went straight to the Prometheus server, and we're getting, you know, so we skipped Thanos and we started getting much better results, instant results. We could look at stuff. So I'm a little bit kind of concerned that the narrative has already become that it's because of the pods, where I think there might actually be a different problem, because if you skip Thanos out, but it kind of ties into what you're saying, but it's not, you know.
I mean, that's there is this set of data.
There's too many series. There's too many. The narrative is that there's too many series because we've moved everything over. But actually, if you go to the Prometheus instances, yeah,
you're querying the same number of series, is what you're saying.
Yeah, and pretty well, it is like maybe a third of them, but the results are instant, right? And you can look over different periods of time and see results. Where in Thanos,
yeah, the thing is,
you can look at the metrics and see nothing.
If you would record that in Thanos and drop all of the like, I'm not saying that the pods or having the cardinality on the pods is the problem. I think the problem is more that they are not aggregated in Thanos. So in Thanos needs to get it all and then spit it all out. While if it was recorded with those labels removed at that point already, like we do for all our SLI aggregations.
So
can we configure Thanos to just drop the pod names?
That's
no, because then if you just drop the pod names, you'd get clashes, right? So that'll overwrite. You'd be, you know, you need to have an aggregation function to say, this is what I should, because otherwise it would be there'd be 10 series with the same.
That's exactly what we're doing with the recording rules there, that the service catalog generates for us.
So what I actually just put it at the bottom of the agenda, but what I was thinking, because you know, we think in apdexes and error budgets and that, but a lot of the engineering teams, they still looking at, you know, histogram quantile, you know, they want to know what the P95, even though it's terribly inaccurate, that's what they're looking for. And they're always trying to do that on the raw data, and that's basically just failing. And I was wondering, we could generate recording rules like that are useful for those quantile things, for all the things that we have SLIs for automatically, and then we can give people the option to run those. But you know what I mean? And then that's what they would use rather than the raw metrics, and then we just have to do some education and tell people about that.
I'm pointing people at the logs most of the time, because generally 7 days worth of data is enough to get that, and it's accurate.
And it's accurate. Yeah.
So like gut feeling, we just don't do the complicated thing where we let the application figure out which metrics it needs to initialize. And yeah, so we initialize per
Because
fleet.
we don't have a problem emitting and storing the data. It's only a problem once we query it, and we would be querying the recording rules and not the raw data.
And this is the part that I'm not sure of, because in the past I've showed you, like on one of the talks, this weird trick that we did to get the feature category onto the HTTP request total metric, and that we're only initializing part of it because not everything is emitted from everywhere. And that was with Ben at the time, and Ben was worried about Prometheus, not Thanos, not querying.
Well, I suppose it depends on how many pods we have to a Prometheus server.
Well, it's basically one Prometheus per cluster. And so we've got the zonal cluster, and then we've got 3 regional clusters. So it's kind of, although all the Sidekick metrics go into the zonal cluster. So the zonal one is quite loaded. And then the regional, sorry, the other way around. The regional one has got Sidekick. That's the big one. And then the small ones have got API Web and Git.
And those are each a different cluster with their own Prometheus?
Yes.
In that case, I wouldn't worry, I think,
Yeah.
because they're all going to get the same number of metrics initialized. Like, yeah.
Yeah. I mean, I looked at it for something else the other day, and those Prometheus were like, they're sitting kind of pretty at the moment. I mean, we should go look through it. You can go look at like what the sample rates on each of them are, and you can obviously just query that at the Thanos level to kind of, but they were pretty good. And one of the things we should ask Mikkel to start thinking about is, how do we add like a second Prometheus? Because with Thanos now, there's no, and all of our metrics and recording rules are happening at the Thanos level. We can kind of break that out in whichever which way. It's just a kind of data collection layer to some degree. But I think the advantage of having everything initialized is, it's much better if we can have it that way.
Well, I like that's good. I want everything initialized, because now, like for Air Budget, I get people creating an issue because suddenly something has moved to Kubernetes, and then the metric hasn't followed yet, and then it does these weird things because the metrics weren't initialized, and that I want to get rid of. It's just easy if you don't need to think about it. But some of the things, like on the Git fleet, we're never going to have the web IDE render, so we could skip initializing that. But that's like the complication, that the application needs to know where it's running, and then needs to make a decision based on that, because that routing lives in HA proxy right now. And so
Sounds like more work, and if we can get away with not doing that work, that would be better.
exactly. That's my thought as well.
But how confident are we that we're not going to knock over a Prometheus when we add those 5,000 metrics?
Right now, since it's one Prometheus 3 times, I think that's probably fine. 5,000 metrics. Yeah. 5,000, like if you look at for example, the GraphQL thing that is also running there, that's orders of magnitude bigger, if I remember correctly.
Well, one thing we could do is query each of these Prometheus servers individually, take a metric that exists across all pods, and do some sort of estimate of how many different, what the cardinality of the pods is, and see if it has a number of how many metrics it can even track. And then we can say number of pods times 5,000, does it fit?
I like that. Let me take a note of that, and I'm going to use that approach to add comments to my merge request, arguing why we don't have to do it or why we should do it. Andrew, you wanted to bring something up?
I think that metric that you can look at for the number in each is called Prometheus TSDV head series. Sorry, I was urgently scrambling to try to find that. I'll just stick it in here. I think that's what it is, if I remember correctly. I'll just stick it in there. This isn't really a demo, but it's just a little heads up. So there's a Project Horse going on, and we need monitoring. And so the first iteration of that was to take the metrics catalog and put it into that project. But I think there was like some concern around, this whole big thing that's quite complicated, and also the fact that there are a lot of other use cases. It's not just Project Horse. It's actually lots of self-managed customers who could use this. So there was a bit of backwards and forwards. I'll just share my screen quick. Sorry, I'll just take that off there. And after a whole bunch of discussion, we ended up deciding that we're going to stick this into Runbooks project for now, and maybe in future we will take this, but also the other metrics catalog, and move them out of Runbooks. But it didn't make sense to kind of have it half in and half out. Like, we should definitely keep this alongside the metrics catalog rather than apart. And it's too hard to take the Runbooks metrics catalog out of the Runbooks, with the timeframes that we have now, and move that out. So we ended up just saying, let's look at putting this in here. And so it's just the start of an MR. But what I'm kind of imagining is that we'll have like several different like topologies, like a get hybrid topology, and that will have its own metrics catalog. Now, a lot of this is going to be
what is get?
Get is the GitLab environment toolkit, which is effective. I mean, this might actually end up being called the reference architecture, the hybrid reference architecture topology is probably actually a better name for it, because that's what Get generates. You could stand up a similar.
You provision all of the environments, and you configure GitLab on them, so you can actually get what Omnibus was doing for a single node across multiple nodes, across VMs, across Kubernetes, and so on. So it's basically an installer. Yeah,
it's a multi-node
an installer
Omnibus
for the cloud.
Yeah, Terraform and Ansible. But yeah, so with Horse, we've actually got this going, and it's deploying, and there's only one service, but it was really just to kind of prove that it worked. And so if you look at Get, and actually if you look at the Helm charts, there's kind of the single service called Web Service, which is a funny name, but anyway. And so, just as an experiment, I created a metrics catalog with this web service. And it's at the moment it's only got a Puma SLI in it, which is like simple, but it's kind of just to prove it out. And what was really interesting is the same customer that Jakob was talking about earlier, somebody who was working on that was saying it's really awful working with the Omnibus dashboards, and we really need to put the SLO monitoring in there. Like, how can we do this? And I think that this is like a really, we can have, if we set up a reference architecture metrics catalog, we can generate this on the, for that customer. We can either give them the YAML and the JSON, or we can, if they say, oh, we've got these other labels or whatever, we can just put them, we can say, well, go and edit your JSON file, wherever the metrics config is, and add the labels that you need, or customize it however you need for your environment, and then run it again. But we can also ship it with like the recording rules and the dashboards, like in the same way we have the GitLab dashboards project at the moment with a bunch of JSON in it, and we could do that. And one of the reasons why I like this is it kind of takes, there's a lot of things that need to happen for Horse, and like just keeping this out is like one less kind of overhead for that, and it also gives other people like a big advantage for being able to use these dashboards. They're not specific to Horse; they are specific to multi-node GitLab.
The thing you're looking to share here is like all of our helper stuff that we have here to define services and so on, or what are you like?
The thing that I want is like, I want a way that people can like look at dashboards and understand quite quickly like the health of a GitLab instance. So it's still very much specific to GitLab instances, and I want to kind of be doing the same thing we're doing on GitLab.com and having the same kind of tied in with the same sort of rates of iteration that we have on those. You know, when I've looked at the Omnibus charts, I don't feel like those give me a clear picture of the health of a GitLab instance. They might tell me CPU and memory usage, but that's not quite the same. And as an experiment, what I was thinking of doing is putting the CI runners into, you know, starting off with if we have a reference, you know, a VM reference architecture, we could start off with just the CI runners in there, or a few of the CI services, maybe the Git service and the Gitly service, and actually ask some of the people that are working with that client to give that a try and see what they, you know, see because they've already asked for this, so we could get that going quite quickly. And give them the YAML and say, here's some rules, apply these rules, and then let's take a look at the dashboards. So it's not really a demo, but if you're wondering why there's like more than one metrics catalog in the runbooks, this is what this is.
So for now, we're not going to extract anything out.
No, but what's quite nice is that I did extract it out and it worked. So we know that the encapsulation of that libsonnets directory is pretty good.
I thought that the way you did it now for Get was pretty cool, actually. Like just importing it directly from the runbooks and just having it live there. We need to be careful not to break stuff if that's going to happen. Can't we figure out something for that first and then decide on extracting later? I mean,
like it would have to live in a different place, not in so I mean, I'm happy to discuss it more, but my main thing is I really want to kind of get on with building up some dashboards, and you know, we can move it out, we can put it somewhere. Like that to me is like a less of a risky decision, but I'm happy to hear different people's opinions, because I know the runbooks is getting really, there's a lot of different stuff in there.
Well, my experience is if you're trying to, I would probably find it easier to work with, to stay in one repo. And to discover what the structure is and where the lines are, where you're going to cut out bits when they're just directories in one repo, rather than commit to having a separate repo and having to work across them. I've had workflows like with Gitly and Gitly Proto, that thing was annoying, and then we went back to having the Proto back in the Gitly repository. I've went through a project of putting Workhorse into the main GitLab repository. There's a if you want to move fast and try things, or if you want flexibility, then not creating projects you don't know you need yet seems like a smart thing to do.
So, I mean, my biggest worry was that people would check changes into the runbooks project that would break the downstream project, and then you like find out, you know, the next time you try run it, and it all becomes, and just having it all together sort of solves that, even though there's a bit of extra complexity. But that's why I ended up putting all that JSONet stuff into ASDF and putting versioning on it and everything, because it's actually related to that, because we need a new version of the JSONet tool to kind of be doing a lot of this stuff.
Yeah, but also, if you're worried about breakage, if it's in the same repo, you can run CI and see the downstream consequences. You don't have to depend on what happens next week somewhere else.
No, so it's I think that's a reasonable thing, but also I'm looking forward to, like, there've been some people that have reached out to me and said like, oh, we want these dashboards, and maybe saying, you know, pinging them back and saying, hey, here's like something alpha if you want to try it, you know, give it a try. And we'll be dog fooding it, so that'll be cool as well.
Or you could, the alpha thing that they could fork could just be like an example like you made now that references the runbooks repository, which is public anyway.
Yeah. The one thing I am kind of worried about is with service discovery. I suspect that lots of people use different job names on the names for jobs in their GitLab instance, and that's going to be kind of because there's no standard on what you call the Giddily exporter. So we'll do things where we'll select job equals Giddily, but someone else, like in Omnibus, has got a different name. It's called like Giddily Prom or something like that. And so they're all different, and that's going to be a bit of a challenge. So it might need quite a lot of customization per customer. But we'll be focused on Get as the initial customer.
Well, it might not be feasible to say we publish a bunch of JSON files and everybody can just post these into their Grafana and it'll work. It may be something that needs a config file that says this is my mapping between some sort of logical service names and Prometheus job names and some things like that, and then that spits out the JSON that they need.
And that's the work that was done like last week. We took as much of that config, all the config that I've seen so far, and we've put it into a single file. And there's one for the Get instance, and then there's another one for GitLab.com. And it's got stuff like this environment has stages, yes or no, so that you don't have like stage label. And there's like environment label, for example, and that's another one. I think type label is going to be there forever because it's just like kind of fundamental to the way we do things. But the other labels, you can configure those, and it's got a whole bunch, like basically all the differences I'm trying to put into one file, and then we can do it that way. And actually, interestingly, if you go look at a lot of the Kubernetes charts, they're all doing this as well. So, all the Kubernetes monitoring, it's all presented in JSON primarily. They normally have like the raw kind of default version in YAML, but all of for lots of different projects, I'm seeing them presenting it as JSON, and then people saying, they say, if you want to change this, put this config in here and change this value, and then run JSON, and you'll get a new file that suits your environment. So it's not like we kind of like completely going against the industry. There's other people doing this.
It also seems unavoidable. Like we don't have standard labels for everything. So you need to have a place where you can configure custom labels and things, stuff like that.
Cool, we're done.
Automatic recording rules for SLIs?
So that was kind of tied in with the last conversation, but that was just, I did not mention it. Maybe it was when I ran away from the snake.
We have those, don't we?
But we don't have, for every single SLI, we don't have a rate. So what I was thinking is for every SLI that's based on the histogram, we generate effectively sum by LE, comma, significant labels, and then the underlying histogram, and then it's very easy for people to do P90, P50, and all of those things.
So you would record histograms, not the success error thing, I think.
Yeah, alongside, in addition, we'll record,
because we have the automatic stuff for histogram applets. We have the automatic success and total counter recordings.
Yeah.
But
this is alongside that, and it comes from this call that I had or this discussion I had with Grzegorz, where he's trying to do this and it's just failing.
But should we be facilitating this at all? Because like Bob said, people should use logs if they don't know if it's exploratory and if they.
So I think
how many of the histograms that we are supporting now are actually like the buckets are. We have 10 buckets that are never used, and then 2 buckets that we look at, and so
I tend to agree. Like I think that's probably better in general but I don't know in this case if it was. I got the impression that these steps, there's like up to 20 steps in a single request, and that you don't want to be logging every single step, right? You don't want to have like 20 log lines per request.
But the separation of each steps inside one log line is okay, like we have for Redis durations, database durations.
Yeah, but this is a variable. This is like a CI. These are sort of CI processes, and so they have it's slightly different. So you couldn't have like 20 different labels for 20 variable steps in a CI pipeline. But I might be wrong on that. But also the other thing is clearly there's something wrong with Thanos, and it's because if you go to the underlying Promethei, it's working much better.
Well, the thing that's really wrong with Thanos is that it plots graphs with white lines on a white background. I think that's just outrageous.
I didn't know that.
I also don't like the fact that it tries to be an editor and it's not very good at it.
I was half joking, but I was getting confused because I was running queries with lots of results. So basically all GitLab methods. And the graph looked like it was at the bottom, and then there was all this white space above. And I thought, why is it sizing the y-axis to have all this white space? And then I realized that one line was dominating everything else, and it was white consistently. Every time I run it, the dominant line is white, and it's
Jacob, welcome to my world. Except it's not white. In my world, it's like cyan.
well,
and everyone's like, oh, but it's cyan. And I'm like,
you can
no, it's not,
distinguish
it's
it from
white.
the background, right? It's not
No, you
cyan on
can't.
a cyan background.
No, but it's cyan on a white background. I can't see that. It's basically like invisible.
Okay, yeah. Well, in this case, switching to classic helped. I don't know if it does any good for you.
I've left classic. I don't use that other one. The other one's not for me yet. Cool.
Okay, I guess that's it.
Yeah.
Bye-bye.
Bye, everyone.